Hey algebra students, today we're going to be solving linear systems, except today we're solving a slightly bigger linear system. Now we've been doing linear systems of two equations with two variables, right? Well, this time we have three equations and we have x, y, and z, three unknowns, three variables that we're trying to figure out what they are. Now, the good news is we use the exact same strategies that we use for the 2x2 systems, okay? That is substitution, elimination. In particular with this one, elimination, all right? So let's just jump right into it. What we see, just like with the 2x2 system, the first thing you want to figure out is what variable do I want to eliminate, okay? And as I look at my x's, I got 5x, negative 2x, 4x. I look at my y's, 2x, or 2y, y, and negative y. That looks pretty good. And I look at my z's, z, negative 3z, 8z. I'm going to go for the y's. Why am I going for the y's? Because 2y, positive y, negative y, they're nice small numbers, and I can combine them very, very easily to get rid of them. So first off, I'm just going to take these two right here, and I'm going to say, I'm going to combine those two. I don't even have to multiply either equation by anything because I have a positive y and a negative y. All I have to do is just add them up. And what do I get? Negative 2x plus 4x is 2x. The y's eliminate each other. And then I have negative 3z plus 8z. That's going to be plus 5z equals negative 4 plus 2 is negative 2. So what's the purpose of doing this? Well, the purpose of doing it is now I have an equation with just two variables, and I'm going to take another combination and get another equation with just two variables, and then I'll have a system of two equations of two variables, and I know how to solve those. So what we're doing is we're taking our kind of complex system and we're taking away a level of complexity, which, you know, that's a good thing. So, all right, next one. What are we going to do? Well, we're no longer taking the bottom two equations. Now we're going to take, the top equation with another equation. And I think we ought to do the top equation that has a 2y and 2 times the bottom equation, okay? So I'm going to take 2 times this one. And so that's going to give me, let me write it right here below it. I'm going to get 8x minus 2y plus 16z equals 4. And now I'm going to add this line to the top line. And so that's going to give me 5x plus 8x is 13x, 2y minus 2y, those take care of each other, and z plus 16z is plus 17z, and that equals 45 plus 4 is 49. So now I have a 2x2 system that I know how to solve, so now I'm real happy, except I look at it and I see, blah, these numbers, they're not very friendly. I'm going to have to multiply, I'm going to multiply the top one by negative 13 and the next one by 2. Why did I choose negative 13 and 2? Because now I'm going to have negative 26x there and 26x there, and when I add them up, they will eliminate each other. Okay, so let's do that. Negative 26x minus 65z equals negative 13 times negative 2 is positive 26. And here I have 26x plus 34z gets me 2 times 49 is 98. And now when I add these up, the x's go away, and I've got negative 31z equals 124. Which at first you think, oh God, 30, no, actually it's not that bad at all. 124 divided by 31 is 4. So that means z is going to be negative 4, because we get a positive divided by the negative. All right, cool. We got one of our variables taken care of. Now we need to find our x's and our y's. Which one do we do first? The x. Why? Because look, I know what z is now, and I can just plug it into one of the, actually, let's do that one, the one with the smaller numbers. I'll plug it into this equation right there. So now I've got 2x plus 5 times negative 4, let's call that minus 20, equals negative 2. Adding 20 to both sides, I get 2x equals 18, so x must be 9. Great. And now the only thing left to do is figure out what y is, and the best way to do that is take my z, this thing here, and my x, this thing here, plug those into any of these three equations, and I'll get my y. All right, I'll just take the top one. It's there. So 5 times x is 45, because it's 5 times 9, plus 2y, plus negative 4, I'll call that minus 4, equals 45. 45 minus 4 is 41, plus 2y equals 45. Subtract 41 from both sides, and you get 2y equals 4, so y must equal 2. And now I've got x is 9, y is 2, z is negative 4. And I'm going to leave it to you to check this by replacing your x with 9, your y with 2, and your z with negative 4 on all three of these equations. And what you'll see is it's true. Hope this helps. Now, I do want to mention that we used elimination to solve these. You don't have to use elimination. You can use substitution. I really find that elimination is 9 times out of 10 the best method to use, though, when you have larger systems of linear equations. All right, like I said, hope this helps, and see you next video. Bye-bye.